Hello and good day, Algebra. We are covering PO47 today. We are shifting from addition and subtraction to multiplication and division. And with that operation shift comes a change in the rules. Okay. With addition and subtraction in both putting polynomials in standard form and with adding and subtracting them, we talked about how the coefficients, right, they are what change. Your exponent does not. 2x squared plus 3x squared is 5x squared, not 5x to the fourth, okay? With multiplication, however, things are a little bit different. And in fact, if you look back at PO7 and CO10, you will find that you've done PO47 before. This is the only time when 7 plus 10 will equal 47. Because multiplying a monomial by a polynomial or a one expression term or one term expression by any number is really just the combination of these two things. So let's review. How do you distribute? 7 times 2x plus 3. What do you do, Colin?
Distribute the 7 each term.
And when we say distribute, what operation are we using here? Exactly. 7 times 2x is 14x. 7 times 3 is positive 21. And our expression is 14x plus 21. Which equals 35x, right? No. Why is it not 35x? Sam?
Oh, because it's
Will?
Because you can't.
Adam.
You can't.
They're not like terms. Pull. Right? They're not like terms. One has an x, one does not. Therefore, they can't be combined. Next one. Negative 8 times 3x plus 4. What do we get? Cool.
Negative 24x plus negative 32.
Negative 24x plus negative 32. Just to be more efficient, we would just write minus 32, but you are correct. That negative sign gets distributed throughout, and we are multiplying. Next one. Who's got it? Maddie.
Negative 15x minus 40.
Negative 15x minus 40. 5 times negative 3x, negative 15x. 5 times negative 8, negative 40. And lastly, you want to say that one, Paul.
Negative 40x plus 90.
Good with that sign. Negative 40x plus 90. A negative 10 times a negative 9 is a positive 90. Okay? So if you understand that, if you understand PO7, and then you understand CO10, which remember was multiplying by the same base, this has been on several bell ringers throughout here. What's the rule for multiplying exponent expressions with the same base? Poldinsky.
Don't you multiply the 4 and the 3?
Yes, the coefficients are multiplied.
The coefficients are multiplied and the exponents are added.
Yes, this is where the exponents change, right? And we can explain that by going back to expanded form and thinking about what this really says. You know, in expanded form, what this really says is 4 times x times x times 3 times x times x times x times x, right? And if we're multiplying these all together, because we can multiply things in any order, we can multiply the 4 and the 3, those coefficients, that's how we get 12. And then how many x's are being multiplied together total? 6 of them, which we can write with the power x to the 6th. So here's that rule shift because of the operation shift. With addition and subtraction, the powers stay the same. Could we add or subtract 3x squared plus 3x to the 4th? No, because they're not like terms, right? But with multiplication, like terms don't really exist. Okay, we can combine x squared and x to the 4th, but the power does change. What would the next one be? Negative 12n cubed times 2n to the 10. What would that be? Tristan?
Negative 24n.
Not 30th, 13th, right? 13th. What's the rule, just as long as we're on it? What's the rule where exponents are multiplied? When would you multiply the powers? Because there is a time when we would. Paisley?
No.
Colin?
When the exponent is to the power of something.
Yes, when an exponent is outside of parentheses. An example would be like 3n squared to the 4th, and we distribute that power in, right? When you have parentheses, then you're thinking multiply the powers. Wait, there are parentheses here. You're right, but there's no power on the outside of them. In this case, these these parentheses are a substitute for the multiplication symbol. Okay, so coefficients multiplied, powers added. Next one, who's got it? 7n to the 7th times negative 2n cubed. Somebody heard me today. Nick.
Negative 14n power.
Good. Negative 14n to the 10th, 7 times negative 2, negative 14, n to the 7th plus or times n cubed, powers are added, n to the 10th. And last one, last but not least, a new voice today. Yes, Galen.
27x to the 11th, y to the 6th.
27x to the 11th, y to the 6th. Nice job recognizing there's a power of 1 with that first y, even though it's not written. Yeah, coefficients, negative 9 times negative 3 is 27. X exponents are added to get 11. The y exponents are added to be 6. Questions on either PO7 or CO10? Whatever you don't finish in class, yes. Okay. But PO47 is just a combination of these two things. Because when we scroll down the page, we've got 2x times 3x plus 8. This is very similar to what we had up top, where it was 7 times 2x plus 3. We put in the 7 to each of them. Now we're just putting in a 2x. Okay, so it gets a little more complicated, but not by much. What's 2x times 3x? 6x squared. What's 2x times 8?
16x.
Who is singing or humming? Why?
I stopped. You were too. I stopped.
Why?
I stopped. I don't know. I stopped.
Okay. 6x squared plus 16 would be our answer. No further. 16x, thank you. No further to go. We can't combine them because one is a power of 2, the other one is a power of 1. And we don't have an equal signs. We can't solve for x, right? We are finished. Nick.
Why is there an exponent of 2?
Because 2x times 3x, when we do that first multiplication, x times x is x squared, right? Anything times itself. Another way to think about it, they each have a power of 1. And when you multiply them, powers get added, 1 plus 1, which would be okay. Another one on this page. Let's keep it to the first 2 rows now, just to start. But anything from the first 2 rows that you want to see explained. Voltinsky.
The 1/2. The next one.
Next one. 8x times 7x squared plus 2x plus 1. Here we've got a monomial multiplied by a trinomial. We still distribute that 8x into each term.
Why not that?
It's just 3 of them. Okay? So start with 8x times 7x squared. I'll kind of write that out here. 8x times 7x squared equals what? 56x cubed, right? Then we take our 8x and we multiply it by 2x, and that gives us 16x squared. And then we take our 8x and we multiply by 1, and that gives us 8x, right? And then our solution is just those 3 terms, our 3 products here, written in standard form. 56x cubed plus 16x squared plus 8x. Okay? That's how we would get each of those 3 terms there. Is taking that 8x and multiplying by each term inside the parentheses. Tristan.
Are you going to assume you have to put it in standard form?
Yes, standard form. It's in the directions, and it's also just expected that you would put it in standard form. I should have used this button. Yeah, standard form. That is correct. Others. We'll open up to row 3 now. If you want anything from row 3, what you got, Maddie?
The 10x to the middle one.
Middle one?
Yeah.
Very well. Middle one in row 3. We've got 10x squared y times 4xy cubed. That's our first multiplication there. And we've got multiple variables, multiple bases in our terms. That's okay. We can handle that. We've done this before. Start with the coefficients. 10 times 4 is 40. Then we have x squared times an x. How many x's is that? 3. X cubed. Right? Then we have y times y cubed. What does that give us?
4.
Y to the 4th. Okay, just add those powers up. Then we take our 10x squared y and we go to our 3xy, multiply there. 10 times 3, our coefficients, gives us 30. X squared times x is once again x cubed. And this time we got y times y, which is y squared. Very good. And our last multiplication, that 10x squared y goes all the way over to the -4. The only thing we need to multiply here are our coefficients, right? 10 times -4 is a -40. That constant doesn't have any bases, doesn't have any variables. So our x squared y just kind of tags along there. There aren't any more x's to multiply by, no more y's to multiply by, so they're not going to change. Okay? And this would be our answer. Pretty cool, huh?
Indeed.
Indeed. Andrea.
I just have a small question. For the next question, so there's a 2y squared and a 4x to the power of 9. How would you put that in standard?
So it's not in standard form currently, right? You would put it in greatest to least power. You don't have to put it in standard form until you're all done, okay? But when you're finished, when you've got, I don't think we talked about this actually, so I'm glad you brought it up. When you've got multiple bases with multiple powers, when you go greatest to least, you're taking the sum of the exponents in that term. So for this one, this is in standard form because this sum would be 7. This sum is 5. This sum is 3. 7, 5, 3. Okay? So when you do your multiplication, you're putting it in standard form. You may have to rearrange things depending on what you have, but you're looking at the sum of the powers if there's more than one exponent in the term. Very good point. Will?
Can we do the one that reviewed that?
Sure. I have to erase my work for this one though to make room for it. So, anyone else have questions on the one I just did?
She keeps laughing.
Yeah. Nathan? Can we be done?
Drawing pictures.
Nathan? Can we be done?
Yes.
Okay. All right. Last one in that second row. -8x to the 5th y squared. That whole term gets distributed to 2y squared. Coefficients get multiplied. -16. No x's in the 2y squared, so our x to the 5th isn't going to change. Then y squared times y squared is y to the 4th. Then into the 3xy, -8 times 3 is a -24. X to the 5th times x is x to the 6th. And y squared times y is y cubed. And then all the way over to that -4x to the 9th, -8 times -4 is a positive 32. X to the 5th times x to the 9th is x to the 14th. And then y squared. So, putting this in standard form, which term is going to go first?
The 32.
The 32x to the 14th y squared, because the sum of these exponents is 16, which is larger than the 9 we have here and the 9 we have here, right? So 32x to the 14th y squared. Now we're getting a little bit nitpicky here, because both of these sum to be 9. So what do you think we do? Which term should come first if we're following standard form? Eli, what do you guess?
I think the 16x is larger than the -16 is larger than the
Okay, going with the coefficients there. Is that right? All right. Colin?
I think the -24 because the x is large. The x power is larger.
Yeah. So everything has to do with the powers here, right? And we said earlier, kind of our tiebreaker was alphabetical order, right? The tiebreaker to the tiebreaker is that alphabetical order, which one's got the larger power. So because 6 is greater than 5, they both sum to 9, but in alphabetical order, x comes first. 6 being greater than 5, that one is going to come next. So -24x to the 6th y cubed, and then -16x to the 5th y to the 4th would be our final answer. Okay. Again, looks kind of super complicated. Tonight might be the night when your parents or siblings look over your shoulder and say, "Ugh, stop asking me for help." But really, it's just a combination of things we've already done. Okay, we're just able to do more with it now, right? Do more with it now. Sam, you got a question? You good?
Yeah.
Okay. Maddie?
Are we really just adding x and y, or the x's, the coefficients together?
We're multiplying the
Sorry.
coefficients,
I meant
the powers
the power.
get added. Yes. Yep. Well,
Can we do the one on the left of the paragraph? Or yeah.
the 5x to the fourth.
Yeah.
That one?
Yeah.
Okay. 5x to the fourth times 8x cubed. Start there. What do we get, Will?
40x to the 7.
40x to the 7th, right? Coefficients multiplied, powers added. Then 5x to the fourth goes into negative 3x to the 7th. What do we get? Someone haven't heard from me yet today. A new voice. I've heard from you. Thank you. I've heard from you. Maybe, Naveen.
Negative 15x to the 11th.
Good. Negative 15x to the 11th. 5 times negative 3, negative 15. 4 plus 7, 11. And lastly, 5x to the fourth times 8. Briggs.
40x.
Excellent. 40x to the fourth. In standard form? No. What's standard form for this one? Briggs?
Negative 15x to the 11th plus 40x to the 7th plus 40x to the 4th.
Good. Negative 15x to the 11th plus 40x to the 7th plus 40x to the 4th should be your final answer in standard form. Okay? Cool.
What if you don't rewrite in like the first or sixth?
There's really not a ton of work to be shown here. What I do want to see are at the very least these lines going in. Because I want you to kind of understand. I want you to show me you understand the process to multiply this. Okay? Because if you look ahead, we're starting with monomials and polynomials. We're moving to binomials and binomials, and then we're moving to polynomials with polynomials. So keeping this stuff organized is going to be pretty important. But otherwise, yeah, not a whole ton of work to be shown here. What's that? No, we only got like 2 minutes left. All right, this is homework for tomorrow. That is how you math.
Don't forget to like and subscribe.